I can divide polynomials as our next objective. I want to remind you of some terms that you may not have remembered from elementary school, and that is when we were dividing, the number that you are dividing is called our dividend, and what you are dividing by is called our divisor. You are dividing by the divisor. That terminology is used in each of the sets of steps for each of the three methods that we are going to talk about for division. The other thing that I want to draw your attention to is this setup for division. I know it looks like multiplication, but because of this -1, that makes this move to the bottom of a fraction, which makes it division. So whenever you see something that looks like this, I want you to rewrite it as division immediately so you don't get confused and try to multiply. That's one of the most common mistakes when students see something written in this form. Now there are three methods that we're going to explore. One method is optional. It's synthetic division. It is the quickest method, and we will use it quite a bit towards the end of the chapter. In my opinion, I think it's the easiest one to use when we are solving polynomials with factors that we already know. But it is limited. You cannot use synthetic division when there are exponents in the divisor. And we don't use synthetic division in this class when there are coefficients in the divisor. So you have to learn and demonstrate either of the other two methods, which are long division or box method, or you might also know this method as polydoku. And you've been exposed to polydoku before, but you haven't seen long division. So that's the one that I'm going to start with. Now I will tell you that I do not usually trend back to long division. This is probably the only problem in the notes that I'm going to use long division for. And that's because historically students have always preferred polydoku, and I've seen more success from students with polydoku. But if you ever want me to work out a specific problem with long division because that's what you're most comfortable with, you just need to let me know and I'm happy to do that for you. So with long division, we're going to remind ourselves of that division process when you are dividing numbers back in grade school. So if we think back to, let's say, 72 divided by 3. We ask ourselves, 3 goes into 7. How many times? 2. 2 times 3 is 6. And then we subtract, and we get 1. And then we have to bring down the 2. 3 goes into 12. How many times? 4. 4 times 3 is 12. Subtract 12, and we get 0. So that is the same basic skeleton process of how we're going to do polynomial long division. We're going to place the dividend on the inside and make sure that your degrees are counting down and that you do not have any missing exponents. This is very important no matter which method you choose. Once you've done that, you'll divide your first term on the outside by the first term on the inside, and that's when your division process is going to start. So I've written out the directions for you here in words. Let's work through a problem together. So the first thing I'm going to do is I'm going to check my dividend. And here's my divisor. I'm going to check my dividend for any missing exponents. It looks like the highest exponent is 2, and I have an exponent of 1, and I have something with no exponent. So there are no missing exponents in this. So I'll write my dividend down. It goes on the inside of my division sign, and my divisor is on the outside. So x goes into x squared, x times, or you can ask yourself the same thing that you do in polydoku. X times what is x squared? So x is my answer. Now we need to multiply. X times x is x squared. X times 2 is 2x. And now we subtract. Just like when we were combining like terms or for addition and subtraction of polynomials, we are going to write our division sign or our subtraction sign in front of each one. So x squared minus x squared, gone. Negative 6x minus 2x is negative 8x. And then bring down. X times what is negative 8x? Negative 8. Negative 8 times x is negative 8x. Negative 8 times 2 is negative 16. And we are subtracting both. So that changes both of the signs to positive. Negative 8x plus 8x, gone. Negative 20 plus 16 gives me negative 4. X times what is negative 4? You can't do that. That means that this becomes part of our remainder. So we will take our remainder and we will add it to the negative 4 over our divisor. So my final answer is x minus 8. And you can choose to keep it as plus and keep the negative 4 up top, or you can do minus 4 over x plus 2. Either one is perfectly fine with me. So that is long division. Now synthetic division is what I like to call our little shortcut method. But remember, it has limitations. It can only be used if there are no exponents in the divisor. We also don't use it in this class when there are coefficients. Okay, like I said, the directions, just like with long division, are set up here. So I'm going to go ahead and get started on the actual problem. So with synthetic division, we have to actually take it and set it equal to 0 first to get our solution. So that means we're adding 4 to both sides, and we get our solution is 4. So that's the number that I'm going to put on the outside. So we have, again, the responsibility to check to make sure that there are no missing exponents. The highest exponent I see is 3. So 3, 2, 1, and no exponent at all. So I don't have any missing exponents. So we'll write the coefficients of each one of those. And make sure that you include any signs in front of those coefficients. So I included the negative in front of the 13 and the 24. Let's bring down the first term. And we have 2. 4 times 2 gives me 8. We like to follow the mantra that I call follow your mama. which stands for multiply then add, multiply then add, multiply then add. So we brought the 2 down and we multiplied. 4 times 2 gives me 8. So next would be adding. Negative 13 plus 8, negative 5. Time to multiply again. 4 times negative 5, negative 20. Add. 26 plus negative 20 is 6. Multiply. 4 times 6 is 24. Add. Negative 24 plus 24 is 0. So since I got 0 at the end here, that tells me that there is no remainder because this would be my remainder number that would have to go over my divisor. But there was no remainder. To inject our x's back into this, we look first back to the degree of this function. Degree is the highest exponent, which is 3, and we go 1 less than that, so 2. X squared, and then x. So since there's no remainder, my answer is just 2x squared minus 5x plus 6. Now let's take a look at Polydoku. For Polydoku, we've already kind of walked through these steps before, so we'll jump right in just like we did with the other problems. We need to check to see are there any missing exponents. The degree or highest exponent that I see is 4. So here's a term with 4, but I don't see a term with 3. So I need to actually put a term with 3 in there. So I'll put 0, a to the third. There's a term with a squared. Here's a term with just a. And here's a term that's a constant. So whenever you have any missing exponents, and this is true no matter which method you choose, you need to check and put zeros in for any of them that are missing the exponent. So find the highest one and count down. And put 0 for any that weren't there. So with Polydoku, we have a divisor that goes on the outside, a plus 2 on the outside. And unlike the Polydoku worksheet, we don't know how many columns we're going to need because we don't know whether there's going to be a remainder or not. So I just draw an open-ended box, and if we use them, fantastic, and if we don't, that's okay too. And this guy becomes my polynomial that was in the circle on the Polydoku worksheet. And remember the rules of Polydoku. The diagonals have to add together to equal each term in this polynomial. And the outsides, the top and the side here, must multiply to equal the inside boxes. So this first box is the only box in its diagonal, so it has to equal the 4a to the 4th. A times what is 4a to the 4th? 4a cubed. 4a cubed times 2 gives me 8a cubed. 8a cubed plus what gives me 0? Negative 8a cubed. A times what is negative 8a cubed? Negative 8a squared. Negative 8a squared times 2 gives me negative 16a squared. Next diagonal, negative 16a squared plus what gives me 2a squared. That would be 18a squared. A times what is 18a squared? And that is 18a. 18a times 2 is 36. 36 plus what gives me 4, and that's negative 32a. A times what is negative 32a, and that's negative 32. And negative 32 times 2 gives me negative 64. And you can see that I didn't draw my boxes long enough here. So I have to add on to them a little bit. And this would be where it would have ended on the Polydoku worksheet. This last number here would have matched here, but that was because all of those did not have a remainder. This guy is going to have a remainder. So negative 64 plus what gives me positive 12, and that would be 76. And A times what equals 76? That can't happen. It's impossible. So this 76 becomes my remainder. Just like with long division, we do plus 76 over my divisor, a plus 2. So my answer is right along the top there. 4a cubed minus 8a squared plus 18a minus 32 plus 76 over a plus 2. Now we're actually going to skip this problem because we have removed that from our standard. Now, actually, in addition, you're going to be asked on your quizzes and on your tests to write any restrictions for these divisions. And the restriction, we'll just go back up and do it for the Polydoku one. The restriction would be what would make this divisor equal to 0. And that's because the divisor, if it was written as a fraction, would be on the bottom. And we cannot have 0 in the denominator of a fraction. So we want to make sure that we avoid plugging in any number for a that would make that bottom of the fraction equal to 0. And so what would make a plus 2 equal 0? That would be if a was negative 2. So we include the restriction by saying a cannot equal negative 2. So we'll start with number 2. Now, how do you know if you can use Polydoku or if you have to use Polydoku or if you can use synthetic division? Well, look at your divisor. So here's my divisor. And the number that's in, or the variable that's in front, as long as it doesn't have an exponent and it doesn't have a number in front, then you can use synthetic division. So I can use synthetic division on number 1, number 3, and number 4. So we'll set this one up and practice some synthetic division. We'll take and make sure that I don't have any missing exponents. 2 is the highest. There's 1, and there's 1 with no exponents. So we will start out by solving this for 0. So subtract 1 from both sides, and we get that a is equal to negative 1. Then we'll go back to our dividend and write down each coefficient. 2, negative 4, and negative 8. Bring the first one down and follow your mama. Multiply, add, multiply, add, multiply, add. Negative 1 times 2, negative 2. Add. Negative 4 plus negative 2 is negative 6. Multiply. Negative 1 times negative 6 is positive 6. Add negative 8 times plus 6 gives me negative 2. So the dividend had an exponent of 2 for its degree. So 1 less than that would be 1. So a to the first, and then they ran out of a's, which makes u the remainder. So minus negative 2 over the divisor, a plus 1. So there's my solution, and it wants me to make sure that I state any restrictions. So a cannot equal, what would make this equal to 0? Negative 1. So a cannot equal negative 1. Number 3. Now remember I said, as soon as you see it written like this, you need to rewrite it with division. So 3z to the 4th minus 6z cubed minus 9z squared plus 3z minus 6 divided by z plus 3. So I can use synthetic division here because I don't have an exponent or a coefficient for the z in the divisor. So check for any missing exponents. Highest one is 4. There's 3, there's 2, there's 1, and no exponent or no variable at all. So let's solve this for 0. Z plus 3 equals 0. We'll subtract 3 from both sides, and z is equal to negative 3. So negative 3 goes outside in my box. And the coefficient of each of the ones in the divisor, the dividend, get written outside with their signs. So 3, negative 6, negative 9, 3, and negative 6 again. And bring the first one down. Multiply negative 3 times 3, negative 9. Add negative 6 plus negative 9, negative 15. Multiply negative 3 times negative 15 is positive 45. Add negative 9 plus 45 is 36. And then multiply again. We have negative 3 times 36 gives me negative 108. Plus 3 gives me negative 105. Negative 105 times negative 3 gives me positive 315. Negative 6 plus 315 is 309. And remember that goes over, because it's the last number, goes over my divisor, z plus 3. Now the highest exponent was 4, so 1 less than that would be 3. Z cubed, z squared, z, and no z. There's my solution. Next one. I can use synthetic because my divisor does not have a number in front and no exponent. The highest exponent is 5, so I'm checking for missing exponents. There's 5, but there is no 4, so y to the 5th plus 0 y to the 4th. There's no cubed either, so plus 0 y cubed. There's a y squared, so negative 3 y squared. There's no y, so plus 0 y. And there's negative 20. If I take y minus 2 and solve it out, I get that y is equal to 2. So that's what's going to go in my box. And each coefficient will be written next to it. 1, 0, 0, negative 3, 0, and negative 20. Bring the first one down. Multiply, add, multiply, add, multiply, add. Follow your mama. Multiply. 2 times 1, 2. Add. 0 plus 2 is 2. Multiply. 2 times 2 is 4. Add. 0 plus 4 is 4. Multiply. 2 times 4 is 8. Add. 8 plus negative 3 is 5. Multiply. 2 times 5 is 10. Add. 10 plus 0 is 10. Multiply. 2 times 10 is 20. Add. Negative 20 plus 20 is 0. The highest exponent is 5, so 1 less than that would be y to the 4th, y cubed, y squared, y, and no y. And since this is 0, there's no remainder. Now we forgot to write a restriction over here. The restriction is what z can't be, and that would be negative 3, because that would make the denominator equal to 0. So z cannot be negative 3. What would make the divisor equal to 0 here? 2. So z, oh, this one's a y, cannot equal 2. Now the last two cannot be solved, or we don't solve them with synthetic division in this class. So we are going to have to use polydoku for them. Or you could choose to use long division for them if you'd like. Polydoku setup would be 3a minus 2 goes on the outside. And I'm going to start off my boxes, but I don't know how long they'll need. Check for missing exponents. Highest exponent is 2, then 1, then none, so there are no missing exponents. This is what goes into my circle. So the first box is my first diagonal, and it has to be 18a squared. 3a times what is 18a squared? 6a. 6a times negative 2, negative 12a. Negative 12a plus what is 6a? 18a. 3a times what is 18a? 6. 6 times negative 2 would give me negative 12. Negative 12 plus what gives me 9. And that would be positive 21. And 3 times something, 3a times something cannot give me 21. So that's the end of the road. So my solution is 6a plus 6 plus 21 over 3a minus 2. And of course we have to list our restriction. A cannot equal, and remember that comes from setting it equal to 0. So if you can see it by looking at it, that's fine. But add 2 to both sides. So 3a equals 2. Divide by 3 on both sides. And a is equal to 2/3. We'll do one more. No missing exponents here. So we have 9y minus 6 outside my box. And this is going to be my circled polynomial. So the first diagonal has to equal 27y squared. 9y times what is 27y squared? That would be 3y. 3y times negative 6 is negative 18y. Negative 18y plus 27. Negative 18y plus what equals 27? And that would be 45y. 9y times what is 45y? 5. 5 times negative 6 is negative 30. So I didn't need the end of my box here because that's already what's in my diagonal. So you can either erase them, or if you don't care if they're long, extra unfinished boxes, you can leave them. It does not matter. My solution, because there's no remainder, is just 9y plus 5. And y cannot equal, we'll have to add 6 to both sides, and then divide by 9 on both sides, and we get that y cannot equal 2/3.